Write each expression below in a simpler form. So we'll look at each of these individually. The first one here, I've got 5 to the 723rd power over 5 to the 721 power. Essentially, I've got 723 factors of 5 over in the numerator and 721 factors of 5 in the denominator. And when they all cancel out, I'm left with 2 additional factors in the numerator still. And of course, you can use the subtraction rule there. 723 minus 721 are 2 factors of 5 left over in the numerator. So your answer is 5 squared, or 25. In question part B, I've got 3 to the 300 power over 3 to the 249th power. When simplifying those, right, 300 minus 249 is 51. So I end up getting 51 factors of 3 in the numerator. So 3 to the positive 51 power. Part C was pretty simple because I'm trained now. If I see something raised to the 0 power, I understand that that's 1. So something to the 0 power is going to equal 1. So I really don't care necessarily what's inside of those parentheses. For D, I cleaned this up so it looks like this. I'm going to be squaring 4 times 10 to the third over 10 to the negative second power. The first thing I did in this problem was I took the 10 to the negative second power and I ran ahead and put that up in the numerator. So this becomes, oops, let me slide this over here. So it ends up becoming, 10 to the negative 2 ends up becoming 10 to the positive second power when I move those up into the numerator. And then I can combine those, right? And now in this numerator, I've got 3 factors of 10 and 2 additional factors of 10 for a total of 5 factors of 10. So 10 to the third times 10 to the second is 10 to the fifth. And there's still the number 4 there. If I want to, I can think about this as I'm multiplying this thing times itself. So I went ahead and just wrote this out as 4 times 10 to the fifth times 4 times 10 to the fifth, which is 16 times 10 to the 10th power, right? If you've got 5 factors of 10 and 5 more factors of 10, that's a total of 10 factors of 10. And if you want, you can slide this decimal place in the correct spot right here and rewrite it so it's in scientific notation. So either 16 times 10 to the 10th, or if you're asked to write in scientific notation, that would be 1.6 times 10 to the 11th power, because I would need one more factor of 10 to put this decimal place back where it was in the original problem.